Hello, welcome to today's math class. We have the math Olympiad question before us here. The question is, what is the sum of the roots log bracket 5 minus 3 to the power of x base 3 equal to minus x? So what is this question asking us to do? We are to look for the roots, whether 2 or 3 or 4, as many as they will be. They add all of that together. That will give us the results we are asked to look for. So if you're new here, this is Math Pros, and if you've not subscribed, do well to subscribe because here we release videos every day, and any of the days we fail to release a video, expect to the next day. So we take our solution as the first thing here. Okay, so now from this question, we're going to look at the log we have here. This log is to base 3. And so I want to express the right-hand side of the equation are also in log base 3. So this is going to give us here log base 3 to the power of 5 minus 3 to the power of x equal to, we have minus x into log 3 base 3. We know from the law of logarithm that our log a base a is equal to what? 1. Okay, provided a is not equal to what? 0. So with this law, here we're going to have 1 from here. So 1 times this will still give us what we have here back. Okay, so according to the law of logarithm again, we can move this to this power here. Remember the law? The law which says that if you have log your p to the power of k, said move this exponent back here. So this is going to give your k, then log p. Okay, you also remember this law also? Good. So we can equally take this back to this place. So if we look at this, we can move the whole of this to this part here. So this is going to give us here log this 3, the bracket 5 minus 3 to the power of x, the close bracket. This is equal to log our base 3, the 3 to the power of minus x. I believe there's no confusion here. Okay, so what we discover here now, the log base 3 and we have here log base 3. They are the same and we have equality sign here. And so since the bases are the same, they can equate the log itself. So this leaves the system. So we're now left with our 5 minus 3 to the power of x. This is equal to 3 to the power of minus x. We can rewrite this according to the law of, right? Good. Which says that if you have your 1 all over a to the power of m, this is same thing as your a to the power of minus m. So this 1 and this division sign takes place of this minus here. So if we subtract to this again, then we can rewrite this. So this will end up giving us 5 minus 3 to the power of x. This is equal to our 1 all over 3 to the power of x. What is the essence of doing this? Why are we doing this? Because here we're having 3 to the power of x already. Now we have 3 to the power of x and we have 3 to the power of x here. Here we can bring in another alphabet to represent what we have here now. So from here, let's do some substitution. So we can say here, let's use the alphabet k be equal to about 3 to the power of x. So whenever we see 3 to the power of x, let's put in k in there. So first, this gives us here 5 minus k is equal to 1 all over k. Then let's eliminate this guy here by multiply through by k. So this is going to give us here k into 5 minus k close bracket equal to 1 all over k times our k here. So k leaves the system on the right hand side of the equation and we'll end up having 5k then minus k to the power of 2 equal to 1. Let's move this to this side of the equation and rearrange the system. So this is going to give us our k to the power of 2 minus 5k. When this comes to this side, we turn to minus, but we multiply with minus again. So this is going to give us plus 1. This is equal to 0. So what kind of equation do we have from here? This is a quadratic equation. So we want to solve this. We cannot use the factorization method here. We want to employ the formula method in solving this. So we know that our formula k, our quadratic formula k is equal to minus b plus minus the square root of b squared minus 4ac everything all over our 2a. So let's systematically bring out A, B, and C. A is the coefficient of A squared, which is positive 1. Then B is equal to minus 5. Then C is equal to the constant, which is 1. So let's do our substitution. So we're going to have your K will now be equal to our minus bracket minus 5 close bracket plus minus the square root of minus 5 all to the power of 2 minus 4 then into what is our A here 1 then into our C which is also 1 then everything all over 2 into 1. All right, so from here, let's continue from here. Now, let's look at this. We want to open up everything here. So this is going to give us our k will now be equal to our plus 5, plus minus the square root of here will give us 25. So we have here 25, minus 4, everything all over 2. Okay, so we proceed from here. We can subtract this from this very easy. So let's continue on this side of it. This is going to give us our 5 plus minus square root of 21 all over 2. Wow. So we have two solutions from here now, k1 and k2. So we have here, therefore our k1 is equal to our 5 plus the square root of 21 all over 2, and our k2 is equal to 5 minus the square root of 21 all over 2. Again, we have to recall where we said let k be equal to something. Where is it? Yeah, we said let k be equal to 3 to the power of x. So from here, we'll now say recall. We'll have here recall that we have our 3 to the power of x is equal to our k. So we're going to take case 1. We have here case 1. Mark case 1, we have this. So we're going to have here 3 to the power of x is equal to 5 to the power, 5 plus the square root of 21 all over 2. Oh, so yeah, we want to take log to both sides of the equation. And what would be the base of the log we're going to apply here? We could as well use base 10, which is the natural base, out here because we want to get our x straight. So we're going to make use of log to base 3. So let's do that. So this is going to give us log base 3 of our 3 to the power of x. This is equal to log base 3, then bracket our 5 plus square root of 21 all over 2 close bracket. So what we'll do here is easy. Move this according to the law of exponent in logarithm to the side. So this is going to give us our x times log 3 base 3. This is equal to log base 3 bracket of 5 plus square root of 21 everything all over 2 close bracket. Really, there's no confusion here. Again, we remember from the law of logarithm, which says that if you have same base, which is this law here, log a base is equals to 1, then this will give us 1 also. So if this gives us 1, we're going to have 1 times x. So therefore, we're going to have our x1 is equal to log our base 3, then bracket 5 plus the square root of 21 close bracket all over 2. So this is our x1. Now for our x2, we're going to follow the same procedure. The difference between our x1 and x2 is just the sign we have in here. Here we have plus, here we have minus. So it's just to change the sign. So therefore our x2 will probably give us log this 3 there to 5 minus the square root of 21 all over 2. Close bracket. So we have two roots here. And again, look at what we're asked to look for in this challenge. The question says, what is the sum of the roots? Here we have two roots. So we're going to look for the sum of the two roots. So we have our x1 plus x2 will now be equal to what? It's just a matter of adding these two together. So we're going to have this as our log is 3 5 plus square root of 21 all over 2, then plus, then we have log our 3, this 3, then of 5 minus the square root of 21 all over 2 close bracket here. Wow. Now look at this. How do we get the answer to this? Here we are having log base 3 and here we have a log base 3. We succumb to the law which says that if you have your log m n, this is equal to log your m, then plus your log your n. You remember this law? Yeah, we call it the product law. Remember this law? All right. So we have this expression, likeness of this. So I want to take this back to this format now. So how do we do that? From here, we're going to have our x1 plus our x2 will now give us here our log of base 3. Then we have 5 plus square root of 2, 21 rather, bracket all over 2, then times bracket 5 minus the square root of 21 bracket all over 2. Okay, so from here, if you check carefully, you discover that this is a conjugate of this. So the multiplication is very, very easy and it's a kind of a perfect one, right? So what will this multiplication give us? So this is going to give us here log is 3, okay? Then bracket 5 times 5 will give us 25. Again, because this is the conjugate of this, so we're going to take this and this. So this is going to give us minus our 21. Close bracket all over 2. Sorry, all over 4. Because we're going to have here 2 times 2, which is 4. Okay, so we can subtract this. This is going to give us here log this 3 into, if we subtract this from this will give us 4. So we're going to have 4 all over 4. And what is 4 all over 4? That is 1. So this is going to give us log this 3 power of 1. From here, remember the law which says that if you have log your 1 base a, this is equal to 0. Okay, so if we subtract to this law here, we are having a similar thing here. So this implies what? 0. So what does this mean? It means, therefore, the sum of the root x1 plus x2 is equal to 0. Wow, this is serious. So this marks the end of this Math Olympiad challenge, which is Dex. From the beginning, we have this. So if you've learned something from this video tutorial, give the video a thumbs up. And if you're not clear in any of the steps we use or apply in solving this math problem, then drop it in the comment section, for we are there to reply to all your comments. We're going to leave no comment untouched this time around. Okay, so subscribe if you've not subscribed, and when you subscribe, turn on the notification button so that you get notified whenever we drop an amazing video like the one you just watched right now. Bye. We will meet you in our next class.